This is GATE 2016 set to electrical question number 42. It says the flux linkage and current relationship for an electromagnetic system is lambda. This is the flux linkage, lambda equal to root over I by G, where I equal to 2 ampere and G is the air gap length. So it is asking us to find us the magnitude of mechanical force on the moving part in Newton. So lambda flux linkage is given to be equal to root over I, that is the current, by G. This relationship is given and the force at a particular point is being asked, where I equal to 2 ampere and G is 10 centimeter. So first we need to determine force as a function of current and air gap length. Then force at I equal to 2 ampere, G equal to 10 centimeter can be determined. This is asked. Drawing the BH curve. All of you know that the BH characteristics is like that, and B is flux phi divided by cross-sectional area. So given that constructional designs are constant, there is no design constraint and all have been designed, so area, length and all dimensional parameters will all be constant. So B proportional to phi, and H is nothing but Ni by Lm, where N is number of turns, I is the current and Lm is the magnetic path length. This is coming from Ampere's law. How? Integral H dl equal to Ni, and H is constant, then into Lm, for example is Ni, H equal to Ni by Lm. And you can assume that BH curve, right? So H is proportional to Ni, which is the MMF, also proportional to I if design constraints are constant. So the characteristics of this is P versus H, or phi versus I, or you can also write N phi equal to Li. So now N phi, this is the linkage, flux linkage, also known as lambda. So lambda equal to Li. So this must be also proportional to N phi because N is constant. So this is proportional to lambda and this is proportional to I. So this is also lambda versus I curve characteristics. dE equal to V into I into dt. Speaking in electrical terms, the energy, there is a elemental energy, is equal to voltage into current into dt. Now V voltage is given by N d phi dt. The H equal to Ni by small lm. So I can be written as H into Lm by N. So writing that I is H into Lm by N, right, multiplied by dt. So now dt gets cancelled. So this is dE. N gets cancelled. H Lm d phi. Now phi equal to V into A. Since B is phi by A, this is flux density. Now d phi equal to dB into A. And let us assume volume of the core is A into Lm. Now rewriting then H and Lm we keeping, then d phi is dB into A. dE can also be written as now H dB into volume of core. Now energy hence is integral h dB into Vc. Now energy density, that is energy per volume of core, can be h dB. So this is the formula. Now you see, this is HBH curve. Also I told you this is phi versus I curve. Also I told you this is lambda versus I curve. So now you see, in this curve, if we can get this area from the limit specified, then this total area will give us the energy density, that is h dB. So this area h dB, integral h dB gives us energy density, that is per unit volume. Now h equal to Ni by L m, and dB equal to d phi by A. Now n phi equal to Li, n d phi equal to L di. Now h, plugging that, Ni by Lm. Now n phi is also linkage lambda, n d phi is d lambda. So also be now written as 1 by n d lambda n by A. So this, now dV can be written as d lambda by n A. Now we told you energy is equal to h dB into Vc. Now here h you see Ni by Lm, you write that Ni by Lm, dB you see d lambda by Na into Vc. Now I told Nn gets cancelled and A into Lm is Vc, so that also gets cancelled. So you see energy is coming out to be Id lambda. So this is energy, right? Now as you come to know that E equal to integral Id lambda, so now you can use this in solving this problem. So energy is Id lambda. Now you see energy equal to work done. So energy stored, what is the energy stored, is work done by external agent. Now equal to integral I d lambda. So I is given out to be, so lambda is given out to be root I by g. So lambda equal to root I by g, and then lambda square g square equal to I. So writing lambda square g square in terms of I into d lambda equal to lambda to the power 2 plus half into g square equal to lambda cube g square by 3. Now this is the energy or work done by external agent, can be said as displacement also. So F force equal to dw dx equal to dw dg equal to d dg of w, that is work done by external agent, is lambda cube g square by 3. This is coming out to be 2 by 3 lambda cube g is coming out to be 2 by 3 root I by g whole cube into g, because lambda is 2 root I by lambda is root I by g. So this is coming out to be f, let us write force to be f, then force come out to be 2 by 3 into, so force at I equal to 2 and g equal to 10 centimeter, careful, centimeter is there. So 2 by 3 into g is 10 into 10 to the power minus 2, writing in meters, all into root 2 whole cube by, so g, this g will get cancelled with this, so this will be a square, g square, so 10 into 10 to the power minus 2 whole square. Then we are getting 2 by 3 into 2 into root 2 divided by 100 into 10 to the power minus 4. So it comes out to be into 10 to the power 4. So this comes out to be 10 square. So 4 root 2 by 3 into 100, it comes out to be around 188.5618 Newton. So this is the answer. So 188.56 is the answer. It is the 188.56 Newton, the force that is acting at that particular point for this given lambda versus I relationship. Thank you.